Hello, everyone. My name is Imran, and I'm a co-founder of Thingtrax. We are an industrial IoT-based startup based in London, and we are set out to make every manufacturing machine smart, regardless of its size, age, and type. So that's what we're doing. So this talk, I'll just talk a bit about one of the specific industry segments that we started working with. I'll now talk about the problems that they face and how we are solving those problems. I've got a couple of case studies to share with you. We can keep it interactive. This doesn't need to be a monologue, so we, ask questions if you want during the presentation. And then we'll talk about a bit about Industry 4.0 and the journey and how you should approach it. Before I start, I just want to ask a question just to understand your interest, area of interest. So are you how many of you are engineers building stuff on IoT and programming? So just an idea. So we've got three people. And how many of you are in business from industrial side of things? Okay, that's pretty good. And one more thing is how much, okay, this gives me an idea to slightly, tailor my talk accordingly. So talking about industrial revolution, without going into the detail, I think we all realize, the changes across time that we've been through, from mechanization to electricity to electronics, and now it's all about cyber physical. It's about connected things, connected manufacturing, and it's interesting, the initial talks that Matt mentioned, and as well as it's all about how to empower people to do more, and as well as so I'll set up a scenario for the problem to set a context. So imagine that you are a manufacturer, and let's say you have 50 machines on your factory, right? Now here's a task for you. I'll set up a scene. So let's say you've grown organically over time, 20 years, let's say. You've acquired machines as you grew. You started with 5, and now you have 10, and now you have 50 machines. Different vendors, different types, different sizes. But your task now is to monitor the efficiency of your production in real time across your factory, how your machines are doing. Let's say your shift started today at 7 a.m. Do you know now, it's around, let's say 11 a.m., how your shift is doing? Are you on track with the efficiency? Is your production on schedule? And how's your labor doing? So let's add another angle to it. So there's machine production efficiency, and then there is labor efficiency. Is your staff that's standing on, let's say, those machines, are they trained? Is there any problems that they're facing? So this is what Industry 4.0 kind of brings to the table, that yes, you can have the answers to that. While you're running your production facility, you can get that real-time information available as and when you need. But what we find out there is, obviously my impression of, I'm from a technical background, and when I used to see National, like Discovery Channel, and I had this vision of factories in my head, which was around, the way they show some of the factories is raw material goes in and nice finished product comes out. Which is true, there are factories that are out there, but in reality, how many of those are that fully connected and fully automated? We have customers here in the UK. We've connected some factories, and we were surprised how manual the processes still are. All the plannings, we've seen rooms full of charts. This is how the jobs are planned. Labor quotas, planning of labor is all still manual on the charts. Production downtimes, there's no visibility of why machines are going down. Somebody will call and say, why didn't you meet my numbers? Oh, because the machine was broken for 2 hours. Why was it broken? That's how, but there's no upfront visibility. And we were surprised how much of that is still the case. So again, the operators don't know, they're invisible problems, there's still manual processes. And the key thing is, I think Matt mentioned as well about real-time data tracking. how much of that is happening, and even if it is happening, how much of that is being made use properly. So we've actually worked with different level of manufacturers, I would say, in terms of technology. So we obviously worked with people who do not track real-time data at all. They have field engineers. You may have heard about the term field monitoring. Sorry, and that process involves people going on the shop floor on every machine, recording data. So they have to record the readings and temperature values, pressure values. They record that on sheets. They come back to the room, type the numbers in an Excel sheet, and try to come up with the numbers. So that's that kind of level. And then there's also people who are actually trying to get data automatically, but then it's coming into a central server. They've invested a lot of money, but then they don't know what to do with it. Is another problem. A lot of that is being analyzed in Excel. Excel is a powerful tool. I love it, but the only issue is you need to know what upfront what you want out of it to design something, to get a metric out of it. What's missing is obviously the machine learning, the intelligence part, which is where some customers are now looking at. They're saying, look, we are connected, but we don't have the intelligence. Can you help us with that? So there's different levels. I think just a bit about Industry 4.0, just a few points here that I'd just like to mention. I think it's all about increasing the efficiency of your machines as well as your labor. When I say efficiency, what do I mean? I mean my production, my availability of the machines. Are they available? Are they running? And the third is quality. What I'm producing, is it a high quality or not? And it's all about tracking that in real time. And it's a blend of people, processes, and technology. I think you may have seen some of these stats, which are, some of these numbers are very interesting actually, that 92% machines in the world are still offline. This goes back to my Discovery Channel example, where you see a nice automated factory, but in reality, a huge amount of machines are still offline. When I say offline, it means they don't provide a real-time monitoring capability. And this is the right time. I think around the IoT hype is obviously, we've kind of been through that. Everybody's excited. They're trying different projects. But I think people are now investing in this. They finally realized that there is a benefit. This is how they're going to get competitive advantage, and they are investing in it. So let's talk about a quick case study. So this is a picture of a factory in the UK. This is a injection molding machine, if you've not guessed it already. It basically makes plastic parts, slightly larger plastic parts. This one in particular makes a whole plastic chair in one go. So one cycle, as we call it. And you can see this is one of our device, which is connected on this machine. I've got another version of this, a different type of device. We've got a few devices in our that we've done. It's interesting how many times Raspberry Pi got mentioned just earlier. The main board in this device is Raspberry Pi. I think we talk a lot about practical examples and how to take things to market. We have gone with this to market. It is commercially live at the moment. We do have our own custom board on top of this. And as you can see, these extra connectors at the top, which you can see after the talk, which help us take direct electric signals from the machines. But we support our program, our code in this is all Python. And we support all industry standard protocols, Modbus, OPC UA, Profibus, Profinet. If there's a machine with a controller on it, this device can read data from it, and it sends the data to our cloud platform. And this is another one of our energy monitoring device. We monitor the energy in real time. I'll talk about this just a little bit more in this example. Apologies for the background color. You may not be able to see much. Now, it's interesting how we've seen. So we've worked with these different manufacturers, and only when we start monitoring this data, we've just realized it's very easy for us to track whether a machine is in production or not. right? Whether parts are moving, it's producing parts or not. But then we saw the trends, and the machinery is out of production, yet consuming massive power. Yeah, that machine that I showed you earlier almost has heaters on them because it melts the plastic, and it's almost like 3 air conditions amount of power continuously being consumed, even if the machine is not in production, because the labor is either gone to get a part or is waiting for a raw material. But what's happening is a lot of energy being wasted here. What we do is, as a simple example, is we send those alerts that if after 10 minutes machine is out of production yet consuming a lot of energy, send an alert. And that alone has made a significant cost savings to one of our customers. I think also when you put such kind of systems in place, the workforce gets alert anyway. They try not to make those mistakes. They try not to leave, for example, a machine running when they know that they can just turn it off or turn certain bits of it off. So they try to follow the processes much better. But this only happens when you start monitoring what's going on. Otherwise, if you have no visibility, then you don't know what's happening there. We also have a live dashboard, as you can see at the bottom. It looks much better now. This is a very earlier picture. We do try and compare because we're now connecting many manufacturers. There are industry standards. It's very similar to when you buy an energy bulb. You see a rating, the green, how green your bulb is. Very similarly, depending upon the size of the product the customer is making, we kind of tell them in a live dashboard that how that particular person or that particular machine, is doing compared to the industry standard. So are you in the green zone? Are you in the red zone? Are you consuming more energy than you should? And that's quite valuable for the customers. The second case study is again around, this is our job planning dashboard, and we use some interesting machine learning. I think this is another one I'd like to share here. I know we talk a lot about IoT, sensors, and data and machine learning, but I think it comes down to practical, small, but valuable use cases, which is what really helps the industry. So a lot of people are trying to do very complex things with machine learning, which is good. But we're trying to solve very small problems, but effective problems with machine learning. Like one of them, I'll give you an example, is around estimated job completion times. So the way people plan jobs, I'll give you this scenario. So if, let's say you got an order to make 5,000 chairs, and you know that your machine takes 2 minutes to make a single chair, you need to now plan the job. The way a planner typically would do this is he would multiply 5,000 with 2 minutes, come up with a time, and then he would add in 20% of buffer at the end, which is a just-in-case buffer, or just in case my machine broke down, just in case labor had an issue. The problem is this 20% buffer gets piled up, and piled up to a massive level whereby you're now taking less orders and you're less efficient. Same labor in your factory, same energy consumption because your machines are running and powering and they're burning energy, but you're making less parts. Whereas what we do is, we look at the past trends. Every machine, shift patterns, labor that's worked on the machine, how many breakdowns it's had in the past, what is a likely more accurate job completion time. And we do that automatically. I think it doesn't show here, but the jobs kind of pile up on the UI. So we show that this job, and then the following job, these are the accurate times that they will actually finish. And this is really helping the customer, not only in the planning side, but also in getting more orders per machine per month. And what is also helping is those manual charts on the wall. So imagine you've planned for 5 months of your production, and all of a sudden a machine is broken. And if you were the planner who drew that chart, you have to come in the morning and do it again. And they don't like doing that. So this kind of acts as a job board as well, where you can simply drag drop jobs around. If it's broken, if one machine is not working, you just drag it around to the second one. So I think just to summarize things, there's a lot of details I can discuss offline. But I think the key thing we are trying to solve is, so the problem I gave you at the beginning was, imagine that 50 machines and it's your factory. If I ask you to think of 2 things in your mind, how much cost roughly you think it would it would be to connect your factory, and how much time do you think it would take? I think these are the key things which are keeping a large proportion of sector still behind because they think it's just not affordable. People like large manufacturers and in industries like especially in car manufacturing industries, and these are advancement sectors. They do have interesting problems of machine learning and data analytics, but they have done kind of basic field monitoring and basic machine monitoring is what they've already done. But even that basic monitoring is kind of out of almost range for a small to medium scale manufacturer, but we want to make it available to everybody. And this is why devices like these, with Raspberry Pi as a base board, are changing that, because they're not, you don't have to break your bank to connect your machine. So this is just a bit about our device, and our key niche is that so I gave you two questions. One was how much time you think it would take, and the second was the cost. So this device can set up on a machine like this within an hour. We've done this. The electricians typically, which are available on site, they were able to install this within an hour, including configuration. It's wireless, that you don't need wires. This is another thing in industry. A lot of old systems, they required wires and SCADA and network setups and servers and IT staff, whereas you don't really need that for these solutions. And there is no capex. You don't have to pay upfront heavy cost. Just a little bit more about when I said devices. This is the one I've got here. We've got power monitoring. And this is an interesting one. It's the labor tracking. We do this for various scenarios. So one of them is health and safety. The other one of them is it's a real-time monitoring of where the labor is and who is operating on which machine. Again, a lot of factories are trying to do lots of different things. There's a clock in, clock out. There's RFID-based things, and the more you have to ask labor to do, the more they don't like it, basically, because it's just too much to follow. With this, they simply carry this tag in their high-vis jacket, and wherever they are, our system tracks their location. It's like an indoor GPS. I can talk about this technology as well in detail if you're interested. But the technology is accurate up to 10 centimeters, so you can almost direct a drone to land on a corner of a table, because it gives you location on XYZ location within a room space. So with this, we can track where the labor is, and it helps. It has to be practical scenarios, practical examples. So for us, a key thing our customer is benefit from is if a machine is making, if it's making parts, but there are too much rejections, right? So the quality is poor. What it really identifies is a quick, maybe that labor wasn't trained enough. So sometimes it involves as little as 5-minute conversation. Go there to the person and tell them what's going wrong, and they understand, and then they immediately see the value, as opposed to traditional way where machine's going to keep making something, it's going, and at some point down the line they will realize, and then obviously things might escalate and it can get ugly. But identify early, identify skills gap early, and take actions. From machine learning side, I can go into the details if you are interested. Again, from the technical point of view, you can see me offline. We are using Microsoft Azure cloud platform at the moment, but our technology stack is pretty much cloud agnostic, so we can run it on Amazon or Google if you wanted to. But again, the power of the cloud platform really helped us go to market quickly, and I think it's very similar to like you were mentioning, that these cloud technologies are really helping getting the scenarios running in a small amount of time. Yeah, that's me. If you want to reach out for any questions that you have, just to give you another quick idea, we do have now customers in 5 countries at the moment. And we're learning a lot from those factories. Every factory is a learning experience, and yeah, it's very interesting. So that's us, basically. Thank you. Cheers.